Hi. Now in this tutorial what I want to do is show you the graphs of sine theta, cosine theta and tan theta, and how the graphs of sine theta and cosine theta are related to displacements on a unit circle. And what we'll do is we'll start off first of all with this displacement y on the unit circle. What I've got is a triangle with a radius of 1 drawn in the first quadrant here. And theta goes from 0 degrees in an anti-clockwise direction to 90 to 180 to 270 and back to 360 degrees. And in this triangle we've got this displacement here, as I say, y, which is defined as being sine theta. You may recall that this is consistent with right angle triangles where we said that the sine of an angle was the opposite side over the hypotenuse. So in this case it would be y divided by 1. And y divided by 1 is y. So for this triangle, this displacement here we're going to call y, which is sine theta. Now what we'll do is we'll take away this triangle and look at how this triangle changes shape and how this displacement changes as we revolve the radius in an anti-clockwise direction round the circle. So when we start from the 0, that is along here horizontal, you can see that for 0 degrees the displacement y is 0. And I've got it in here that displacement for 0 degrees is 0. And so we've got the point here on the axis that at 0, y is 0. Now when we move round to 30 degrees, you can see that our displacement y turns out to be this height here. It turns out to be half a unit, 0.5 high, if you were to measure this. And when we get round to 60 degrees, the displacement increases to 0.87. And then at 90 degrees, it reaches a value of 1 at the top here. So we'll just mark that in as 1. Moving on to 120 degrees, the displacement starts to decrease. And you can see what we get now for 150 and 180 degrees. And as we go round, we now start to get negative displacements at 210 degrees, 240 degrees, until we get to 270 degrees, and this gives us our lowest point at -1. Now as we work our way round to 300 degrees, we get -0.87, 330 degrees, -0.5, and at 360 degrees, we're back to 0. Now you can get these values just by using a calculator. Make sure you're in degrees mode and type in the sine of any one of these angles. Sine 150 degrees, check it out, you'll get 0.5. Sine 120 degrees though is rounded to 2 decimal places. So by using your calculator then you could plot these points on a graph. Now not only can we rotate in a anti-clockwise positive direction, but we can rotate clockwise in a negative direction. We start with an angle of 0 degrees. When we get down to here, this is -90, -180, -270, then -360 degrees. And if we look at the displacements y as we rotate in a clockwise sense, then we can plot the graph for values from 0 to -360. And it's going to look something like this. We can draw up a table going from 0 to -360, and when we have our first value for 0 degrees it's going to be 0, and then for -30 degrees we've got -1/2, and so on. Now we can join these points up and we get the familiar sine wave. And this graph doesn't have to be limited from minus 360 to 360 degrees. It can carry on. If we were to go to 390 degrees, we'll get 0.5. The graph would just carry on like this, out this way, and it will go up and down as you see. And the same here. It's going to come down like this and go up and down, oscillate. Okay, well that's the sine graph. Now we need to look at the cosine graph. Now if we look at the unit circle again and take our triangle where the hypotenuse is the radius of 1 unit, and we've got this angle theta in here turning from 0 degrees all the way to 360. Well, I've got this displacement x, and x is equal to cos theta. So just write that in there. Now this is consistent with what you should already know, that cosine is adjacent over hypotenuse. So this is the adjacent side, so cosine of theta would be x over the hypotenuse 1, and x over 1 is x. So we can think then of sketching the graph of x equals cos theta as we move round the circle. So as we go from 0 to 360 degrees, we're going to get something like this. And now as we go from 0 to minus 360 in the other direction, we eventually end up with the final graph going from minus 360 to 360 looking something like this, which when joined up gives us the graph of x equals cos theta. Now it's not normal to see the graph this way round, so what it normally looks like is this, where we have y equals cos theta instead of x, and this becomes the y-axis, and our graph goes from minus 360 to 360, and you can see that the graph would also carry on beyond minus 360 and beyond the 360 degrees, oscillating as it does. Now as with any graph, you can draw up a table of values. Like in this one, I've drawn up 0 to 360 degrees, and you could use your calculator, as long as it's in degrees mode, to work out the corresponding values for cos theta and plot them. And the same applies if you want to go from minus 360 degrees to 0 degrees. Now it's well worth comparing the two graphs of y equals cos theta and y equals sine theta. They both have exactly the same wave pattern. They have what is called a period of 360 degrees. That is, they repeat every 360 degrees. And also you'll notice that the sine graph, y equals sine theta, is a translation of the cosine theta graph by 90 degrees to the right. Or you could argue that the cosine graph, when compared to the sine graph, is a translation of 90 degrees to the left. Now we only have one more graph left to do, y equals tan theta. And this is an interesting graph. It's totally different from sine theta and cos theta. Now I've got some axes here going from minus 360 to 360 degrees. And if we wanted to plot this graph, draw up a table and use your calculator to work out various values. And I've got a table here going from 0 degrees to 360 degrees, and if you type in tan of 0 degrees you'll get 0, tan of 30, 0.58 to 2 decimal places, and so on. Do the same for going from minus 360 degrees up to the 0. Type in your values, build up a table. Now if we plot these values on the graph, you're going to get a graph looking something like this. But if you look carefully, you'll see that I've left out the values at 90, 270, minus 270 and minus 90. Because if you were to type these into your calculator, you'd get an error. Or some calculators might even display undefined result. That's because when you get closer to 90 degrees from the left-hand side, your values get bigger and bigger. They tend to plus infinity. And when you go beyond 90 degrees, like 91 degrees, you get a big negative number, tending towards minus infinity. And the same applies to the 270, minus 90 and the 270 degrees up here. We have what is called asymptotes. The curve approaches these values. Now it's also worth noting that this graph is periodic. Each one of these patterns repeats every 180 degrees. So it's periodic with a period of 180 degrees. So in summary then, we have the three graphs: y equals sine theta, y equals cos theta, and the graph of y equals tan theta. And it's very important then that you try and remember these graphs. You'll be called upon to sketch them on many occasions. Okay, well, that brings us to the end of this tutorial, and I hope that it's been of some use to you.